వనిత 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 నేను వింటున్నాను. వనిత 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 వైషు ఇంకో లోపలికి తెచ్చిస్తావా? ఆప్షన్ కాదు కదా.
Good evening, all. I hope you are doing well. We'll start the session. Shashank sir, you can take over the class.
Sure. Thank you so much.
Thank you.
Right. So we'll start the session. So first of all, good evening to all of you. And let me just so I've shared the data set. You can download that. We'll start the session. So first, as I told you yesterday, first of all, we'll go with the you know first of all, the deep learning aspect, which is using the healthcare data set, like ECG data set, right, for heart disease prediction. First, we'll do that quickly. We'll go through that project, and then we'll go with the NLP thing, right? So we'll try to understand what is NLP and implement a project in NLP. So now let me share my screen. So I've shared the data set. You can just access that data set. Yeah, even ma'am was also shared. You can just download that. So let me uh, share the screen. Yeah. Fine. So now we'll quickly go through a very simple project in deep learning for the heart disease prediction. So for this, let us use a data set, a short and sweet data set, which is the ECG data set, right? And let us try and implement some of the models when it comes to deep learning, and let us try to predict whether our model is able to predict whether the person has a risk of having heart attack or not, okay, or a heart disease or not. So now let us try and use this. First, let us see the libraries which are there, right, which we are actually using to implement, right? And if you see, there are a bunch of libraries which are actually used, right? So basically, they consists of different things like, for example, NumPy, Pandas, right, Matplotlib, Seaborn, so which you're already aware of, right? Or we have already done some understanding on that libraries as well. So you can see sys also system. So that is basically for the system specific parameters. Okay. And anyway, NumPy, Pandas, Matplotlib. NumPy and Pandas is basically used for numerical computations and the data manipulations and the data frames and all. You can use Pandas. Then comes the Matplotlib and Seaborn for creating visualizations, and basically they are used for exploring the data as well. So after that, you can see some of the machine learning machine learning libraries which have been used, right? Like the sklearn, right? Because even though you are doing a deep learning project, if you want to use some of the metrics like the classification report, model selection, accuracy score, all these things, you have to import the sklearn, right? So you have to implement the sklearn. So here so we are implementing that model selection part, classification and all, right? So model selection is basically for training and testing, cross validations and all those things. And then the classification reports are basically which to get the report where you can see the F1 score, precision recall and all those things you can actually see. So after that, the next important thing is the this is a bunch of you know libraries which are actually related with the deep learning part, which is that's why I've segregated between this that part, and I've just given a gap as well. So here you can see that there are a bunch of libraries which I called, right? And these libraries are basically all are used for deep learning aspect, right? And let us see what are these basically. So anyway, to implement TensorFlow and Keras, we'll call Keras and TensorFlow, that already we know. And the first one is the basically categorical. Categorical is for using or creating one hot encoding, right? Or to give you segregate the classification or categorical variables. So the next thing is the sequential. Sequential is basically used for creating a layer by layer model. Okay. Then the dense. Dense is basically for fully connected layers, right? So creating a entire connected layers, right? In a deep learning or a neural network, we can say we use the dense library or a module. So next is the Adam. So basically Adam, you're already aware of. Adam is basically used for optimization, right? So this is one of the methods which is actually used for updating the weights, right? So mostly during the back propagation. So then next is the dropouts. So for dropouts, this basically dropout is used to prevent from overfitting, right? So it is actually a regularization technique, which is so this dropout will help for this dropout will help for the supporting for which is used for supporting the regularizations. I would say, yeah, that would be a fair word to say. Okay, and then we have the regularizers where you have both L1 and L2, which is lasso and ridge regularization. So next thing is the early stopping. So early stopping is something where it actually helps the model to basically prevent from overfitting or underfitting. So you know it tries to stop the training. It tries to stop the training when the model is actually going maybe not only just underfitting or overfitting, like either of them, right? So both, so it will try to prevent it. So yeah, in that aspect, we can use the early stopping aspect. So this is what some of the libraries which or you can say modules or functions which we are using, right, which are required for our project. So now with the data sets already which I've shared you can see the ECG data set. So this data set has some of the ECG reports, right? And there are certain factors, right? So using these certain factors, we have to predict whether the person will have heart attack or heart disease or not, right? And the data is given such a way that the person has this kind of age, right? This is the height, this is the weight, right? And his BP, right? So ECG, how the wave is, or how the data is actually is, right? And how many years of smoking he has, whether he'll smoke or not, right? So like that, we have different kinds of parameters which are involved or which are actually existing inside the data set what we have actually taken. So now considering the data set, what we have, concern the data set what we have, we have just read the data set or we have read the data set. So let us here you can see that some of the columns are not ideal actually, right? It says smoke, right? So smoker will be an appropriate whether that person is a smoker or not, right? So what we are trying to do is we will rename that columns. Okay, so there's a small function which can use data.columns. So what this will do is this will rename the columns, right? Whatever we have in the what we have read in the Python environment. So this will not rename in the original data set. So original data set will be the same, right? This will be renamed only inside this Python notebook where you have actually called the data set into. So here you can see that we have kept the age and sex same. Instead of smoke, we are putting it as smoker, right? And for years, we are renaming it as years of smoking, right? So that will give a better idea that what exactly the person what exactly the data is about. So years of smoking, you can see some 45, 17, and so on in the data set. And then we have the cholesterol level, which is the LDL, like which is the level of cholesterol. So we are taking the levels from 1 to 4, right? So it has been categorized. Sorry, levels of cholesterol, we have the level actually, yeah, 69117 and all. The next one, we have the levels of chest pain. So chest pain type, right? So we are giving 1 to 4. Okay. So we are given, levels of how much of chest pain the person is having. Then we have the height and weight. We are not changing anything. And then FH is basically the family history. So whether that, person has that smoking habit in the family or not. Okay. So next is activity, right? And in the activity, whether the family, what kind of actually this activity is basically, uh, does he do some I can say workouts or something like that, right? And then the lifestyle. So, which kind of lifestyle he leads, right? Because that is also very important when it comes to, predicting the heart disease prediction also, because it is based upon the lifestyle, what, people are actually living. So then we have the cardiac intervention, right? And then comes the heart rate. HR is the heart rate. And then the diabetes, right? And then the blood pressure, systole and diastole. So systole is the upper number, 120 or some, 120 by 80 is the ideal number. So systole is for the top number, and diastole is for the bottom number. So then the hypertension, whether that is having, because hypertension plays a very important role, whether they're having hypertension or not. So then the interventricular septal end diastole is there or not. And then the ECG pattern, right? And how it is, on which level it is from 1 to 4. And then the Q wave, whether it is there or not. Okay. So that is also one of the parameters for predicting the heart attacks. And then we have the target variable, which is the person with 0 doesn't have a heart attack, and the person with 1 has a heart attack. So now let us go into, first with the describe function. So whatever, here you can see whatever, some of the things for that you can calculate the statistical summary part, which is the count, median, standard deviation, quartiles, and the maximum value. So for some, it makes sense. Years of smoking, it makes sense. For sex, it doesn't make sense, right? So age, it makes sense, right? So cholesterol level also, it makes sense, right? So chest pain type, it doesn't make sense because it is on the left. It's a categorical variable, right? So weight, again, height and weight, it makes sense. So like that, whatever is a numerical variable, it will make sense when you calculate. So whatever is categorical, for example, levels of, so for this here activity, you can see for activity, it is 0 and 1. So, it doesn't make any sense because it's a categorical variable, whether it is, calculating the statistical summary. So you can only consider for those, or you can also give that whatever are numerical, you can calculate for those, for those only you can calculate the, but describe function. Okay. So, or you can just, you can check for whatever numerical, for those, are you doing it or not? Okay. So going to the next part, tail. So tail is the last observations of the. So next, let us see the EDA part. Okay, quickly. And here you can see that the percentage of missing values, right? So we are using the same isNull.sum function, and we are calculating the percentage. And if you see carefully that there is no missing values in the data set. Okay. So after that, let us go to the plotting a histogram. Okay. So to see the distribution of the data set. Okay. So for example, if you see the years of smoking, the data is not distributed properly. For example, sex we cannot see because there is no it's not a numerical value to see the data distribution. So since it is plotted for everything, you have to see for which. For example, for weight, it is more of a bell-shaped curve, right? Not ideally, but somewhat better. But height is also not distributed properly. So like that, you can just check for how for the numerical values, whether it is basically statistically distributed or not. You can actually check. So now going forward into the next one, here you can see that most of the things are not balanced properly, right? So hypertension, it is zeros and ones, and they are mostly equal. So ECG pattern also, it's but QF is not. Zeros are so high and ones are very low. So ECG pattern also, so this one, even the diabetes also not that great. So yeah, some have their ups and downs. So there's always a problem with these kinds of data sets because you have more people who are not having heart attack than who are having heart attack. So it is very difficult for these kinds of data sets also. So that is why yesterday, I was telling about the data generation part also, where the generation of a synthetic data set is extremely important. When it comes to particularly medical diagnosis. So synthetic data sets actually really help for us to to build models. So that's what our journey of the technology development in deep learning and AI is actually working towards generation of data, right? For the generation of data, so that so training model building, and because sometimes availability of data becomes very difficult. So based on that, this synthetic generation of data sets is actually playing a very important role in the kind of market right now. So now, so going into this part, we have plotted the graph, right? And this one is done. Sorry. So this part is done. Let us go to the next part where you can see the, let us plot the graph. Okay. Particularly, leaving you can see the target part also. Okay. So target part, particularly, we are targeting uh, how many are there basically. And one more thing is the most important one is always the count plot to check the imbalance in the data set. So this is very important. If there is imbalance in the data set, we are going to use the technique of SMOT, which will balance out the data set. So here you can see it's a small data set which I have taken, okay, just for you to show that how we can build for heart disease prediction as well. So here there is a, even though the data set is small, still you can see there is a lot of imbalance in the data set. So this is what actually happens. This is what actually happens with the, particularly medical data. So the yes cases will be lesser compared to that of the no cases. So always there is an imbalance, particularly in the field of medical data. So that is one aspect, which always needs to be taken care of when we are doing the analysis part. Right. So next one, let us see the distribution across the age. Okay. So let us see the distribution throughout the age. So you can see that our data set has, age starting from 20 to, till it goes till 90, right? And here you can see in that age distribution that 0 indicates the person doesn't have a heart attack and 1 indicates the person having a heart attack, right? And you can see here, orange, where at the age of 20, this person is having a heart attack, right? And you can see here 45, there are a few people, right? And here there is no people with heart attacks. So yeah, it's like when you cross this 34, 35, you can see everywhere that, and it gets more when the data goes by, right? And these 20s are some of the exceptional cases who are under a lot of pressure, maybe stress, right? So it can happen. It can happen in some of the cases like that. So now going down, let us plot the graph for sorry, please. So let us plot the graph for the correlation. Let us plot the graph for correlation. Let us plot the heat map. And you can see, the darker it is, more negative correlated it. Hello?
సరే నరగ్రాఫా నీకు ఒకటి చూపించా
Sure, I'll share some of the things. I'll just inform ma'am as well. Time series one, I guess I've shared, I guess. Fine, I'll just check. I'll just share in this session also again. Okay. Yeah. Fine. So more darker you can see, the more negative correlated, and lighter it becomes. It is, more towards the, you know. So yeah, you can see that, more negative. Here you can see the positive. Like, yeah, more lighter. It is. Just give me a minute. Okay. So more lighter it becomes, it is more positively correlated, and more darker it is, negatively correlated. So going down, you can see that we are splitting the data set, right? And before doing that, before basically splitting the data set into, training and testing by, X-train, X-test, and Y-train and Y-test. The most important thing what we have to do is we have to segregate the independent variables and the dependent variables. So the first one, what we are doing is the independent variables. So in the independent variables, you will get everything, right? Except the target variable, what we are trying to predict. So let us keep this target variable for the dependent variable, which is the Y. Okay. So after that, what we are trying to do is we are going to apply, mean and standard deviation. That is basically standardization. So we are doing that standardization part for the, for both the for all the H values, whatever is possible, it will apply. So then next one is the training, splitting the data set, training and testing. So X-train, X-test, and Y-train and Y-test. Okay. And here we are using the model selection, right? Model underscore selection dot train underscore test underscore split, right? And X and Y. And in the random state, we are, going with the standard, random state, which is the random state 42. And the test size, we are taking it as 0.2, right? So the testing data is 20% and the training data is obviously 80%. So any one you can give. So either it is train underscore size or you can give test underscore size. So any one is fine. So now let us go to the next part. And here you can see that in the Y variable, basically Y train and Y test. So the, the data what we have is basically a categorical variable, right? So it is basically zeros and ones, right? And now let us, use this function. It is a very important function, which is what we have discussed. So we have to monitor the loss function and the mode, right? And, this mode is basically to predict, which one, which you have to go for a minimum or a maximum. This verbose is for triggering an alert, right? So you can see here I've mentioned also. So verbose is basically for triggering an alert, right? So when when it has to actually trigger, basically is the before it is basically how many epochs it has to wait before it underperforms before it starts to trigger. Okay, so that is what this is one of the very beautiful method. This is one of the beautiful methods in Keras. Okay, this early stopping, which is a very useful function, which is a very useful function when it comes to Keras and TensorFlow, particularly in Keras. So next thing is building a neural network, right? And let us try and build a neural network first. The first thing is we are trying to add the layers. Okay, so model.add sequential. Already I told you what is a sequential, and here this add function adds the number of layers into the and into the model. So this input dimensions are the number of dimensions we are actually giving the model. And this 64, what you are seeing here, 64 indicates that number of neurons. Okay, so basically the formula is basically 2 power n, right? So we can give a 2, 4, 8, 16, 32, 64, 128, even 2, 6, 5, 12. So we go by the formula 2 power n to give the number of neurons in each neural network. So here you can see that 264 is given here. You can see 32, 16, and 8. So that is up to you how many neurons you want to give, which you want to be, you want to build in a neural network. So this is the number of dimensions what we have. Okay, and here we have given the dropout as 0.2. So basically this dropout 0.2 is basically dropout is dropping at 20%. So if the neurons go below the dropping level, which is 0.20, right, we stop training, because this will if it goes below what is which is not supposed to go, it actually pushes to overfit. Okay, so to avoid this, we give this dropout. Basically this dropout actually helps you that it doesn't overfit. Okay, so this is one of the advantages what we have when we use the function dropout. So coming to the next part, even the regularizations we have given. So here we have mentioned the L2 regularization, and here you can see 0.001, right? So the 0.001 indicates the learning rate. Okay, so that tells you how much of learning. Here I've also mentioned, I guess, yeah, you can see it here. So 0.001 is basically denoted by alpha, and it is the learning rate in the model. Okay, right? So I hope I've mentioned everything. All small details also I've mentioned here for a clear understanding. And activation function, I'm taking the ReLU activation function here. Okay, and here also I've mentioned activation functions is nothing but the mathematical or the statistical functions to build each layer inside the neural net. Okay. So I can remember like this. Okay. So here for the regularization, I'm using the ridge regression, which is the L2 one. Okay. So L1 is basically the lasso. Okay, maybe I'll mention this here. So L1 is lasso. I think you're aware of anyway. So L1 is lasso and L2 is basically ridge. Okay. So these two are basically used for regularizations that do different kinds of regularizations what we have. So I think apart from that, I think everything is fine. Yeah, we kept on adding from 64, we went to 32. So here we are adding 1 layer, 2 layer, 3 layer, 4 layer, 5. So we are adding 5 layers to the neural network. Okay. So you can see between the input and the output, you can see 5 layers which will be built. And here, the first 3 layers consists of ReLU. Okay, ReLU activation function. And the rest two, have consisting, one is of the activation functions softmax. So I've mentioned because it's a multi-class classification. And for the for the last layer, I've mentioned the sigmoid function. And the most important thing is compiling the model. So for compiling the model, I am using the Adam optimizer. Okay, I'm using the Adam optimizer. And here I'm giving the entropy, cross entropy. I'm using the Adam optimizer, and I'm using the matrix accuracy. So already you know all these things which exist where when it will calculate the accuracy score. So now here again same for learning rate. I told you 0.001 is a very is a slower way for the model to learn. But what it will happen is it will capture all the features which are required, particularly in a particularly in a neural network. So it is very important for having a slow learning rate, so that the model learns in a very good way, right? And this one I've shown you yesterday. I've given the 64 layers, and then from 64 it went to 32, 16, 8, and 2. Okay. So yesterday you have seen the autoencoders. Autoencoder is where you encode and decode. So that is a bit different from what exactly we do. So now going to the next part, which is training the algorithm, right? Basically fitting the model, which is basically called as a training. And yesterday I've discussed also about this epochs, right? And I've given the and I've given the batch size. Okay. So I've given the batch size. The batch size is nothing but the sample size. Okay. Since the data is small, I've given the sample size as 10. Okay. So batch size is nothing but the sample size. Epochs are nothing but the training cycles. And callbacks here is nothing but the ES is nothing but the early stopping, which we have already defined here. You can see here, ES is nothing but the early stopping. Okay. By using the all these monitor mode, verbose, and patience. Okay. So the same ES we are defining here, which is the early stopping in the Keras library. So next is we are evaluating the model as well, testing the accuracy of the model. So here you can see that the accuracy starts from 52%, and that is for the training accuracy, which starts at 52%, and the validation accuracy, which starts at 56%. Okay, and here you can see the loss function of the training is 0.72. And the loss function for the validation accuracy is 0.71. So you can easily identify validation loss or validation accuracy is for the testing data. Accuracy and loss is for the training data. Okay. So I've just trained. So simply I've given some 50 epochs. Yesterday I told to try with 500, 1,000 epochs. I don't know how many of you have tried, but if you have tried, you would be noticing that the amount of time it takes to run, and maybe a better accuracy and more accurate the model actually can train. So now if I just go down, this was a small data set. So basically the training is a bit more faster, right? So you can see the steps being performed very easily, right? Or you can see in a faster way, right? And you can see that the model accuracy, which has actually, you can see that here at the last, the accuracy is around 91%. So 91 was the accuracy, around 90%, 91% is the accuracy. So 91 for the validation, it is 91, right? That is what it is showing here. That is for the validation data set. For training, it is 91.23. If you can see here carefully. See here, 91.23 for the training data, and the loss function is 0.27. Okay, and for validation accuracy, it is around 91.04, which is shown here. Okay, and the validation loss is also 0.2734. So basically they both are almost the training and the accuracy of the training data and accuracy of the testing data, and I can say loss function of the training data and loss function of the validation data set. They're almost all are they're very similar or nearby to each other. So that is one thing which has to be understood. So now going forward, let us also build a graph to check the accuracy of the model. Okay, and you can see that both the training and testing both are around 91, which actually tells you that there is no overfitting or underfitting. Okay, so if the training data performs well, maybe 91%, something like that, and your testing performs at only some 40-50%, something like that, then you can say that it is overfitting, right? But here in this case, it's not overfitting because both the training and the testing data set is actually performing well, right? So above 90% and all. So it is basically there's no problem of overfitting or underfitting in the data set. So next, we'll also predict the loss function. So it is very important that the loss functions are also very nearby, right? And we plot there also, they are pretty much nearby, correct? And next one is, using the classification report or creating a classification report. And here we are building a classification report which will give you the accuracy of the categorical model what we have built, right? This is a again this is the perfect value what we got, 91.044. So, and then we have the precision and recall. So precision is very good for the prediction of zeros, right? And recall is 0.84. So when we take the harmonic mean of both precision and recall, the F1 score is around 0.91. And for the predictions of 1, it is 0.83, and recall is around 1, and this is also around 0.91. So they're basically fine, somewhat okay with the predictions part, and you have a support and for both zeros and ones. So now let us predict. So since we have built a model, let us predict by giving a data point, right? So let us give this data point. I've passed a data point, right? In this data point, you can see that age, what's the person's sex, he's a smoker or not, he's having, how many years of smoking, all those things I've passed, whatever I got from the customer, or you can say the patient, right? Because here heart disease prediction, so it's a patient. So, whatever I got from the patient, I just passed it, and, a new record or an unseen data point, right? And I'm trying to predict the accuracy of the model, right? So for predicting directly, I cannot just pass the data in the form of a dictionary and I cannot predict. So what is the thing I have to do? I have to first convert into a, data frame, right? This is very important part when you actually, pass a new data point to check whether how much the model accuracy is actually performing, right? The first thing is to pass a particular, convert it into a data frame, then use the standardization method, right, which is the mean and standard deviation method, then applying converting into arrays, then applying the predictions to predict the probabilities, then converting the predictions into class tables, which is 0 and 1, and then printing the value, right? And now, passing in some of the things, okay? So I've given this optional, but, I feel if you pass this, this will be better also to understand, how much the model can do, right? So here you can see that, if you see the probabilities here, you can see that 0.34, 34% is for the 34% is basically for the zero class, and 74% you can see for the one class, right? And here you can see that since the more probability is there for one class, right, and the true basically the true level for this class is also 1, right? And here you can also, if you have not passed, but we know that that person has heart attack, so the true level is 1, okay, and the accuracy is also 1, because it has predicted correctly, because 74%, since it's a classification problem, whatever is above that threshold value 0.5, here we have put the, basically it takes 0.5 as a threshold value, so whatever is above the 0.5, right, it takes as 1. So the true level is also 1, and the accuracy for the model is also 1. The prediction is also 1, because 74% it has predicted that the person is having a heart disease. So that is how you can predict, using the models what we have actually built. So if you have any doubt, yeah, I'll share the project, sir. Some people are asking. I remember also I've shared the things. So I just maybe I can share it once again. Okay. So time series is what some of you were asking. Just give me a minute. Time series I remember sharing, but it's fine. Let me share. No problem. So Adam is an optimizer, Prakash. It's an optimizer. Yeah. So I've shared this time series one. You can just download that, Sayed. Yeah. It is not like gradient descent. Adam is actually a family of gradient descent. Don't say like. Yeah, it is. Yeah, it is a family of gradient descent. I told you also the story behind this already. Again, if I tell that, many people will follow the story again. So yeah, I'm not going to tell that. So yeah, story of Louis Cauchy, Augustine Louis Cauchy finding the gradient descent. Yes, so from there it starts, and finally it came to the new optimizer. What is being used in the current day for deep learning is the Adam. So it has been yeah, it has evolved over the years, and so it is one of the best actually best optimizers, I would say, going around. So whenever I use it, I always find myself using Adam more often than not, and that much it is powerful also. So I would say I support Adam, and I creates a very good model, a very good optimizer which we can work around. So even this one I'll share. Just give me a minute. So the one which we have done now also I'll share. Yeah, I've shared it. Heart disease prediction. So in the meanwhile, yeah, you can download these two projects what I've shared, and in the meanwhile you can also you know ask any doubts. So this one is done. I've shared you guys also. You can just download that. And one more important thing is, let me share you the. So one more dataset link I'm sharing. You can just download that. I think ma'am has already shared it. So again, I've shared. So it is the, for NLP, I've shared the dataset. Okay. So particularly for NLP, I'm not going to dig so much deep. Just briefly, I'll cover some of the concepts. What exactly is NLP, and we'll just go with the project. Okay. So what exactly things happen, or what is basically NLP and all the stuff I just talk about. Okay. So what happens in NLP? Why we are using NLP? So that just briefly I'll touch up. So maybe if you have any doubts, you can just ask me, or else I'll just move on with the NLP part. So let me open the. Share my PPT. So meanwhile, if you have any doubts, you can ask me. I'm just waiting, just wait for a couple of minutes, and then maybe I'll start. So tomorrow I have some project suggestions. I'll tell you some of the projects which I wanted to tell. So some capstone projects I just wanted to give some suggestions on, which you can implement also in the future. So I'll keep this in mind also, right? I've prepared some of the list, what ideas you can have, maybe like a brainstorming where you can think of certain ideas which you can implement, which are some may be existing, but you can do modifications, and some which are not existing. Some creative, some of the things I'll be discussing also. So that also we will talk tomorrow. Yeah, and we'll see one project where. So how is neuron different from perceptron? Perceptron is a multi-layer neural network, Sayed. It's a multi-layer neural network. So due to some time constraints, I didn't cover all that much depth of neural networks, right? So just briefly, I have explained yesterday what is neural network and all. So I've just, this perceptron one I've not covered. So this is basically having a multi-layer, network is basically a perceptron. So because usually, as I told you also, the deep indicates in, deep learning indicate, sorry, the deep in deep learning indicates that how deep the model, actually goes, right? So how many layers that particular the model actually, how many layers it takes, and more the depth, that much more the model becomes complex, and it is difficult for us also. So it gives, maybe, too complex models are also not good. That is what I feel. There's a certain level of where you can actually go building that level of, layers of network to get an output from your input value or the inputs. So any other questions? So if we don't have, maybe I can just start with the probably I can start. Just project where we use audio device to accident detection. So I wanted work. Okay, you wanted to work. Maybe two is missing, I guess. Yes, on a project where we use a lot of IoT devices. Okay, we use a lot of IoT devices for accident detection in bikes and cars. What are your comments on it? Yes, you can use, particularly when you write a particular piece of code. Basically, IoT devices, I'm familiar with, where we use sensors to detect the data, right? To process certain aspects of it. So you can actually use or build a certain project, using the IoT devices. So it's a great way of communicating, helping the, using this natural language processing, text pre-processing, these Keras and tensor flows, machine learning algorithms for a better, safer, or a very good projects which can help us, to predict these kinds of. So even, I can say, particularly, these, AI generated, signals also, which are actually transforming, the way the, traffic signals also work. That is also one area. That is also one area where AI is, transforming. AI is transforming, things, right? So I don't know, you're aware of it or not, because even the traffic signals are using this AI to detect the traffic and to change the signals accordingly. So and any and face detection, all these things, and, everybody is aware. Maybe you would have also seen the movies also. So at the signals detecting whether you're wearing a helmet or not, right? Whether you are talking on a call, something like that. So so a lot of things have come up implementation wise and all. So this using of these IoT devices actually helps this processing even more faster, or helps to uh, have more I can say, to know more or to build more, and yeah, it's good for the society as well. So that is one thing I can comment on. Sir, we can create our one application to develop modules. What is this ISR? Not okay, sir. Okay, okay, okay. We can create our own application to develop. Yes, we can do, but I think you understood, some of the things we cannot cover because of the time constraint. So even I was, telling you about an example of deep learning as well. So if you're not able to cover a lot of things in deep learning, right? Even NLP also, just briefly, I'm explaining some of the things, when it comes to, NLP also. Okay. Fine. I guess I'll just continue. Okay, I'll just share the screen. Just give me a minute. Okay, so let us see that what is exactly NLP, natural language processing, right? So it's a branch of artificial intelligence which is focused more on training the machines about the natural language. Okay, so training the machines on the natural language is what the main focus of that is what the main focus of NLP basically is. So keeping this in mind, so what exactly we are making the machine to learn? So how the machine actually learns the natural language, right? So for this, what we are trying to do is we are trying to process huge amounts of textual data, right? So based on this textual data or whatever we are processing, right? We are building or training a model to tell the machine that this is how things work, right? So right from the concepts like the tokenization, parts of speech tagging. So those who have already learned NLP will be understanding more what I'm actually speaking about as well, right? So let us go forward in understanding what is this text pre-processing is basically is. So the most important components when it comes to the NLP, one of the main important things is the text pre-processing. So here, when it comes to text pre-processing, the most important or the most important aspect when it comes to text pre-processing, the first one is the tokenization, right? So tokenization is nothing but giving tokens to words, right? So giving each word one particular number, right? And breaking them or breaking down into different, or small words, right? By giving tokens. Then we do the normalizations. So normalizations are nothing but removing the unnecessary things in the data and bringing it to the standard format. What exactly, in what way it is helpful for us. So stemming and lemmatization again are a very important factors when we have to train the data, right? So particularly bringing the data into its original form or the root form. For example, like running. So for running, we can say run, right? So that is more than enough, right? So bringing the data into a standard form or to its root form is what basically the stemming and lemmatizations are more focused on. So next is the stop word removal. So for stop word removal, so these are some of the words which, for example, like the and, is, or, the, right? Small words which doesn't give a lot of meaning in the data, right? And these stop words are needs to be removed, or eliminating these stop words or common words are must when we want to process the NLP part. So next is the POS tagging. So POS tagging is nothing but the parts of speech tagging, right? So like the noun, pronoun, right, adjective and all. So it is a very important to learn, because we are teaching the machine the natural language. So obviously when we teach the natural language part, you also know that when you learn English, right, obviously you learn English grammar, right? So parts of speech and all those things. So the same way we identify the parts of speech also in the natural language processing, right? Because it's the same how we learn, we are the same way we are teaching the machine as well. So next thing is the core techniques, what we use particularly when it comes to the natural language processing NLP. So the first thing is the parsing. So parsing is a very important thing, right? Which is actually basically used for analyzing the structure, or particularly the grammatical structure. Because a very simple example I'll tell you. For example, if you have to use a voice assistant, for example, like a Google Assistant or Amazon Siri, or any kind of voice assistant, if you have to use, the most important thing is, if the voice assistant has to understand what you're exactly saying, it's a very important that the sentence has some meaning. That is what also the next thing is comes into the picture, which is the semantic analysis also. The words, the sentences, the grammar has to make sense. Then only, or else if you give a sentence which doesn't make a meaning, right, grammatical wise, or the words doesn't give meaning, your Google Assistant, or your Amazon, I can say, your Siri or any kind of voice assistant will tell that the sentence is not framed properly, or it's not able to understand, right, what you are trying to ask. So that is why it is very important, because voice assistants are one of the classical examples of to see the implementations of NLP in action. So just like how you learn English grammar, or how you learn the grammatical structure of how to frame a sentence, the same way we actually train the machine as well. So how you learned English language, the same way you have to teach the English language also to the machine. So that is what this parsing is about. And then the semantic analysis. So parsing is basically we called as a syntax analysis as well. And then the semantic analysis, which already I've discussed. So next is the NER, which is the identifying the proper nouns, places, organizations and all. Then the sentiment analysis, which is basically used for identifying positive, negative, all those emotions and so forth. So next is the topic modeling. So here we try to collect different kinds of topics and try to analyze the data on that particular aspect. So next is the language modeling. So here we are predicting the next word in the sequence. So this is basically using the probability methods. So if a particular sentence you're about to write, right, and if you're about to write a particular sentence, you can just identify that what is the probability that what can be the next word. You can see this prediction part when it comes to maybe email, right? So it might be an email. So when you're writing an email, you can see that there is a suggestion, right? So what you can write, right, or what can come, correct? So that is a classical example also. NLP in action. You can see that the word which is suggesting, right? That is basically a word which has the more probability, right? So for which has the more probability of occurring, right? So that word is basically suggested by your Gmail or any other models which you are trying to write. So next is the advanced techniques like the word embeddings, right? So for the word embeddings, you have some of the models like Glove, right? Or you can say GLOVE. Then we have word to vector conversions. Then the transformer models. So we also have spoken about this, data generation models as well, right? Like the BERT, GPT, and all those things. And then the attention mechanisms as well. So like the text summarizations and all those things. So you can see these advanced techniques like the text summarization, particularly in maybe you can see some of the AI features in mobile phones, which cost more, like speech to text conversions. And then you have some of the features, for example, in the Pixel phones or Samsung Galaxy, high-end phones like S24 Ultra and all those things you can see. So there is some of the features like you can convert the call into a text, right? So that particular application comes under the advanced techniques like the summarization or the translation. So for example, like the call what you are speaking can be converted into a text like a summary, and like a text message. So that features are implemented, which is a proper application of natural language processing. Okay. So next is the use cases of NLP, for example, like the text analytics, right? Particularly when it comes to the social media or sentiment analysis, particularly, right? And then we can talk about the chatbots, right? Like the I've just spoken about Google Assistant, Alexa, Siri, right? All those intelligent agents, we call them. And then the translation, which I have already spoken about, machine translation is between, converting between different languages and also converting speech to text conversion as well. So document classification also, based on the information in that particular email, whether that particular email is a spam or not. So you can also identify, those things, right? And next is the search engines where you can provide, accurate content through the different search engines. For example, like the Google search, and you can see the content recommendations also. For example, like the YouTube or Netflix or Amazon Prime, right? Hotstar, certain kinds of OTT applications, or not even just those. You can also see it in e-commerce websites like the Flipkart, Amazon, and so on. So next in the healthcare, you can also see how the NLP powered chatbots and all, which actually help you to chat with the chatbot and analyze any problem. So whatever it has been trained on, whatever suggestions it can give, it will help you to solve most of your problem. If still that problem persists or that particular problem cannot be solved, maybe it will ask that it will connect to its customer care or something like that, right? So mostly it will try to solve by itself, right? So you can see chatbots in everywhere, for example, like a Flipkart, Amazon, right? So you can see in different kinds of websites you can see the chatbots, right? So next in the finance field, automated reports in financial, that is what these NLP has also brought to the table. So content generation, we have already spoken about content generation, so much of times, and that is what basically the future is about. So when we talk about content generation, we are talking about the generative AI part. So next is the education, where we use the plagiarism check tools. For example, I think everybody are aware of Grammarly and Turnitin and all those things, which helps you to check the plagiarisms, right? And next is real world applications. And there are some of the libraries which we use in the real time. For example, so we use some of the libraries in the real world, which some of them like the NLTK. So NLTK is nothing but the natural language toolkit. So this is one of the pre-processing libraries which can be used for tokenization and all the basic NLP tasks. So next thing you can see is the Spacey. So Spacey is also one of the bigger libraries, I can say, which supports the processing of the text. And then you can see, one of the most famous library. This is actually, built on the structure of transformers, right? So for generating the text data, particularly like for BERTs and chat GPTs. So maybe this name is new for you. We have something library called as a Hugging Face. So Hugging Face is a library which is built on the technology of transformers. Okay. So this BERT and GPT, the chat GPT and all, they use this Hugging Face transformer to generate the text, what it is actually giving you. So next is the GenSim. GenSim is also particularly for word embeddings and building. You can use the GenSim library. Then obviously you're aware of this Keras and TensorFlow, and you also have the PyTorch library for building this deep learning models for the NLP tasks. So implementation is the same, like how do you implement a deep learning part, but only thing here is you are dealing with the text data. So preparing the data and all, and then converting into numerical representations like word embeddings and all those things, back of words, TD-IDF and all those things, tokenization, all those things, you are converting it. Then you are training the text by using the algorithms like the Naive algorithm, SVM, neural networks, example, and so on. So then you build, evaluate them by using the precision recall, right? All those things. Then you deploy the, project into the web services or the mobile applications. So when you see the NLP in action, right? So you would have already understood where you are actually seeing natural language processing in the real world, right? So for example, best example is your Google search, right? So you process a lot of text by searching, right? The queries what you give are used for training purposes, right? So building the transformer models, right? And then you use the Alexa, so Amazon's Alexa also, where it converts or combines the speech recognition on the commands. So whatever is from voice to text, it will convert from voice to text. So you speak voice, but you don't know that it will convert into a text. So it cannot process directly the voice commands. It will convert into text and then it will execute because it's a machine, right? Since it's a round thing, you cannot see that it is converting into text, but it will convert into text, which Amazon will use for training purposes. So it will convert to speech to text, and then it will react. That's why it takes that split second to convert into text and then process the data. Then you have the Grammarly part, which is used for tons of applications, for example, spell checking and all those things. And then obviously your OTT applications. One of the examples is your Netflix. So then the LinkedIn, where you get the similar kind of job descriptions. So it is based upon the recommendation systems. So now let us also talk, some of the challenges, right? The challenges is, always the first and the foremost challenge I wanted to mention is the ambiguity. So this is the biggest problem, when it comes to, particularly, when it particularly comes to, natural language processing. So the biggest challenge is the ambiguity where one word, multiple meanings. So, explaining the model, explaining the model that what is the context for that particular situation is the toughest part when it comes to the natural language processing. As a human being, you can understand that what is the context in that particular aspect, but as a machine, it is very difficult for the model to predict. That is what our challenge also lies. And then the capturing the long dependencies or long range of words is also a toughest problem in NLP, right? And it is limited to some of the languages only, particularly like English. And also ethical concerns are also there, which actually leads to biasness also. So next is the real-time processing, where also processing the text in the chatbots is also one of the challenges which actually we are kind of facing right now. So now what I'll do is, attendance ma'am has shared. I think you can just use it as well to fill your attendance and give the feedback also. Yeah. So let me share the project. Let us discuss that. Uh, let me take some questions. There are predefined applications, sir. So we use machine learning algorithms and generate new applications where there is no predefined algorithms. Get the question properly. Can you just rephrase it? What you meant? You're asking that you want to generate new algorithms which are not existing. So you can develop your own algorithms that you can do. So, but you have to be, more into the field of machine learning and deep learning, and you have to be also in the field of research to develop new algorithms and define a new model, new algorithm which can help the data to learn and predict the outcomes. So yeah, a lot of applications are there. Yes, not just machine learning, also deep learning, and also the some of the AI applications also. That's what you're asking, maybe. So attendance link is will. So attendance link is opening actually. I'm just checking also. It is fine. I don't know why for you it is not opening, but it is opening. Uh, yeah, I've just checked. It is fine. So I think that should not be an issue. Yes, ma'am. It is fine actually. Sir, in Word 2, it is a pretend not what it is. So first of all, I'll get no, sir. I mean that we can use machine learning to generate new applications, sir. Yes, we can use machine learning to generate new applications. That is absolutely right only. Okay. So where is the question in that? You're only telling that we are using machine learning to generate new applications. Yes, you can use machine learning to generate new applications. So I'm not exactly understanding what you're trying to ask. Maybe uh, uh, I don't know. I got one more question. Let me answer that. Yes, Om Prakash. I'm just taking your question only now. So I've seen that word to vector, is it pre-trained model or what it is? So basically, word to vector, I can say it is a word embedding technique. I would say that as a word embedding technique. So to explain that in a deeper sense, this is a word to vector is a method which is actually developed by Google. Okay, so I think it's been some 10 to 12 years, something like that. I'm not exactly remembering when it has, somewhere around 2012, 2013, something like that. It's been developed by Google's team. So this word to vector is basically it's a method or it's a model. I can say it's a neural network model. So that is one thing. And if I remember correctly, there are two kinds of things in word to vector. One is this bag of words, and one is the skipping the grams. So that's what it is. So if you want deeper explanation, I have to go deeper into the concept. So it is like bag of words. So based on the context of the sentence, you can use it in the project. Absolutely, yes. You know, so you say you didn't say can we use. You're saying we can use in our project. Yes, you can use. So your answer is only sorry. Your question is only your answer. So you can use it. Yeah, yeah, no problem, no problem. Uh, so there are predefined applications now. So instead of that, we can create. Yes, you can create your own applications. I'm not saying no, no. I didn't say no. Okay. Okay. Fine. So basically, this word to vectors are, I just wanted to tell one thing. These are basically used for clustering and finding similarity between words. Yeah, and for recommendation systems, right? So yeah, so for these mostly, I remember using word to vector. So it is basically, converting low dimensional vectors. So semantic analysis. So this uses the technology of concept of cosine similarity also. If I that if I just speak about that, it goes a little deeper into NLP. So this can be word to vector. As far as I remember, I've actually used in TensorFlow and PyTorch. So I don't remember using in GenSim actually, but even in GenSim you can use this word to vector. So but the most difficult part is for word to vector. You actually need a lot of data. So a lot of text data, and yeah, a lot of text data is required for training the algorithm. So that is one aspect when it comes to uh, word to vector. So maybe you can ask any other question apart from that. So I'll share the project on, one project on NLP. Maybe you can just go through. Okay. So just wanted to discuss also that, but due to some time constraint, I'm not able to do it. So maybe you can ask questions, or maybe for a few minutes we can discuss the project also. So that is also fine for me. So maybe I'll just give me a minute. I'll just share the project. Okay. Let us just. I hope you have downloaded the data set. I'll just share because I have some important things to discuss. So let me just start the project. Okay, so this is one of the applications I just wanted to tell you also. This is a hate speech reduction, particularly in Twitter. Okay, now we are calling it as X, right? And you can just see that how people put their comments, how you can analyze what kind of comments we are getting, how to calculate, or how to understand the sentiment analysis that we can actually calculate, or we can understand by using the NLP. Now, if you just see the top part, which is using for visualization, NumPy, pandas, for warnings and all, right? This is basically used for consistently sizing the plots. Okay. So maybe any questions you have, you can keep it for tomorrow. Okay. So in just these 7 minutes, I'll just explain the project. Okay. Let me you know let me take the questions tomorrow. Okay, I'll take whatever you have tomorrow. You can just come up with questions tomorrow. Okay, so yeah, so this one is basically used for resizing the plots. Okay, or sizing the plots perfectly into the Jupyter notebook. So next thing is the most important thing, and the first, and which you have not seen, is basically these things. Okay, so these are very important, which you have not seen actually, right? The most important thing what you can see is there are some libraries which are under the process of NLTK, right? So NLTK is nothing but the natural language toolkit. Okay, so in that you have certain modules. You can see here all NLTK, NLTK, NLTK. In that you have certain modules called as the stem and tokenize and corpus. These are some of the corpus is nothing but a bank. It's like a bank which contains all the stop words, right? So how in a normal bank you have money which is deposited, like that you have something called as a corpus bank, where you have all kinds of stop words, right? So like is, and, the, right, we. So all these stop words are mentioned in that corpus of in that bank, which is called as a corpus. So next is the tokenization. So tokenization is basically of two types. One is sentence tokenization and one is word tokenization. So you are giving one word as one token, or you are giving the entire sentence as a token. So that is based upon which kind of tokenization you are actually trying to apply. And next is the word punct. So basically this this punct is nothing but I can say for giving tokenizations for particularly punctuation of words. Then you have the tweet tokenizer. So because we are using the tweet data, and then we have the WordNet where so WordNet you can say WordNet and Porter stemmer, right? These are the two stemmings we are using. So WordNet lematizer is used for lemmatization, and Porter stemmer is basically used for stemming, right? And RE is basically used for regular expressions. Okay. And going to the next part, you can see that something called as a text blob, right? So text blob is basically, this is one of the very important, one of the very important applications which is used for sentiment analysis. Okay. So this text blob, you can remember that it is mostly used for, sentiment analysis, right? And this counter is basically used for word frequencies. Okay, so it is basically used for word frequencies. You just remember like this. Okay, so this is and this text blob is basically used for sentiment analysis. Okay, and word frequencies are basically used for counter is basically used for word frequencies. And going to the next part, yeah, training and testing, you already know. Yeah, this is one is very important, TD-IDF, right? So this TD-IDF is basically using to converting text into numerical, I can say text into numerical representations. So this is basically the concept of, I can say vectorization or vectors, or this is also for transformer learning. So these are basically in the sklearn.features. Okay, you can see this TD-IDF. No, so next is the logistic regression part, right? So we are building mostly, we are going to use the machine learning models when it comes to using an NLP mostly. So naive Bayes is one of the classification techniques which is very useful, right? And we also have the logistic regression. Here you can see multinomial NB, right? So this NB is nothing but the naive Bayes. So as naive Bayes algorithm is basically used in the or it is there in the sklearn library. So next is this part you already know, accuracy score, right? So actually you can write this in one part, right? So this because these are all metrics, right? So you can write accuracy score F1, right? And you can write the classification report also. Okay. And you can also write the confusion matrix. So you can simplify like this. Even this text extraction, you can actually, because these are also, these are also one. You can simplify like this. Okay. So you have the, you have the vectorization and the transformers into one. Okay. So this can be filtered into one. So same like this model selection where you can filter it into one, because all these are also model selection, right? So stratified fold randomization, and also we have the cross validations, right? This one also I can put it as one. Okay. So yeah. So whatever, even for the tokenization, you can bring it into one. Okay, so you can put into word tokenization and sentence tokenization, and you can also put word punctuation tokenizer also as one, and even you have the tweet tokenizer, right? So that is also can be put into one. Okay. So it will simplify the code as well, which you are using. So this one also it's stemming, so you can use the WordNet lematizer and Porter stemmer into one. Okay, so text blob, feature selection, naive Bayes, metrics, all these things you can mention here. Okay. So fine. So tomorrow what I'll do is I'll just go quickly. I'll just finish this Twitter hate speech recognition, okay, classification technique very quickly, because I just want to discuss some of the project ideas also for project ideas as well. Yeah. So project ideas also, let me, for the capstone project, I just wanted to discuss some ideas as well. And after that, we'll discuss a few questions, whatever you have and all. Okay. So maybe that, just so maybe that we can end. Okay. It's already 9. Shushmita ma'am, you can take over.
Yeah, sure, sir.
Yeah, if they have any questions tomorrow, they'll ask. I just told the same thing.
Yeah, okay, sir.
Yeah.
So yeah, we'll wind up for the day, sir. We'll meet again by tomorrow at 7:30.
Sure.
Thank you, sir. Thank you so much for your valuable class. Thank you all. Thank you for joining the session. Good night, everyone. We are winding up for the day. Thank you.